Electricity comes to us through a system with three parts: generation, transmission, and distribution. Behind me is a power generation station. It burns fossil fuels such as coal, oil, or natural gas, in this case coal. But the fuel source could also be water or a nuclear reactor. These fuels are converted to electrical energy using generators. Recall that when electrons are forced to move from atom to atom, electricity is produced. Generating stations don't store electricity. Once produced, the electricity moves through a system of cables and wires from the power plant onto a transmission grid, where it is carried along wires strung on tall towers or poles. The voltage in these wires is extremely high, in the range of 60,000 to 500,000 volts. The transmission lines eventually feed into substations like this. These are transformers, which reduce the voltage to lower levels, between 4,000 and 25,000 volts. In most cases, the wires with the highest voltage are those at the top of utility poles. And keep in mind that most poles have other utility wires, such as telephone and cable. The voltage is still too high for practical usage inside buildings, so smaller transformers, either on utility poles or the ground, called pad-mounted transformers, lower the voltage to levels usable at home and in factories. The wires which extend from poles on the street to buildings are termed service drops. At this point, electricity comes into homes at 120 and 240 volts. Things which might draw the higher voltage are spas, air conditioning units, or clothes dryers. Most lights and small appliances operate at 120 volts. However, special industrial applications can require more power, usually 277 and 480 volts for their needs. We've all seen lightning flashes extending between the sky and the ground. Electricity, whether from lightning or a power line, is seeking a place which has zero voltage, like the water containers reaching equilibrium. The term grounded is derived from the earth being at ground voltage, zero voltage. Electricity energizes things. Whether it's a lightning bolt or a power line, both things are termed energized. A circuit is the path the current takes as it moves and includes all of the parts of the electrical system. We're taught at an early age to avoid being shocked from electrical outlets and appliances. But as a responder in an emergency situation, it's vital that you treat every potential source or conductor of electricity as if it were energized. Keeping this in mind could save a life, including your own. Only when a utility company's on-site expert informs you that they have de-energized the area can you assume the electrical hazards have been removed.
Okay, power's off.
Let's review some of the concepts in this area before moving on. See if you can match the words with the correct part of the electrical power system. Fossil fuel applies to generation. Towers and 70,000 volts apply to transmission. So does transformer, but that's a bit of a trick because it also applies to distribution, as do 120 volts and meter, because voltage is constantly being lowered for usage throughout the system. Which term describes anything which has current running through it? Vulcanized, ionized, or energized? The answer is energized.